We present an augmented reality predictive display to help mitigate the effects of delayed telesurgery. Currently, teleoperated surgical robots are used within hospitals such as the Vinci Surgical System from Intuitive Surgical Incorporated, as shown on the right. Remote telesurgery is currently not feasible due to the latency between the operator and the bedside robot. Predictive displays have been developed for other applications of teleoperated robots and help mitigate the effects of latency by giving the operator immediate visual feedback. Previously developed predictive displays cannot be directly applied to remote telesurgery due to the complex obstacles such as tissue and the kinematic accuracies required in a surgical setting. We developed a complete and efficient system that we call a Stereoscopic AR Predictive Display, or SARPD for short. It is the first predictive display for teleoperated surgical robots. An extended common filter strategy is used to track the slave tool arms in real time in order to provide an accurate prediction. An efficient AR rendering procedure was developed to display the kinematically predicted motions on a stereoscopic display. The AR renderings are overlaid on the delayed image data for stereoscopic cameras. We conducted a user study and found that when using SARPD, there is a decrease in time to complete tasks while having no effect on error rate. Here is a flowchart for a general teleoperated system. The master sends a target pose through the communication channel to the slave. The slave then actuates to the target pose and supplies visual feedback, which once again is sent through the communication channel. The EKF is applied on the master side to correct a hand-eye transform between the bases of the slave arms and the camera frame. It utilizes both the encoder readings and the visual data. The AR prediction uses the corrected hand-eye transform and the predicted joint angles calculated by inverse kinematics to kinematically set the virtually rendered tools. Finally, the stereo rendering overlays the virtually rendered tools on the delayed camera data stream to give the operator immediate visual feedback of their motions with the delayed complex environmental data. A video of the ring handoff under 1 second of delay when using the stereoscopic AR predictive display is shown. Even with the corrections from the EKF, there are other kinematic inaccuracies that aren't accounted for in the prediction of the slave tools. In initial studies, we found that inaccuracies cause confusion when making small, precise motions. Therefore, we applied a dynamic transparency so the AR prediction will assist only when making large motion. A peg transfer task was used as a sample task for the user study. Participants were given enough time before each trial to overcome the learning curve of the system and the environment. Each participant was tested with no SARPD and a round-trip delay of 0 seconds, no SARPD and a round-trip delay of 1 second, SARPD and a round-trip delay of 1 second. The user study was conducted with 10 participants. It found that SARPD on average decreased time to complete tasks by 19% and had no statistically significant effect on error rate. No effect on error rate is expected since the error prediction does not show when making small, precise motions, which is when the errors for this task occur. For future work, we aim to improve the prediction accuracy by using both left and right image data streams from the stereoscopic endoscope and supply them to the EKF so there are more detected features. We also plan to track the joint angles in the EKF to further improve the accuracy of the prediction.